Thanks, Mike. Okay, hello everybody. Really excited to be here. I know it's after lunch. You're kind of tired, but bear with me. We'll do some cool stuff. Oops. Yeah, straight to the point. Right. Spoiler alert. Right. Okay, so a little bit about myself. My name is Vladimir Novick. This is my actual website. I work as a software architect at Code Value. I do stuff in web, mobile, virtual reality, mixed reality, and Internet of Things field. And recently I published my book on React Native. So if you want it, just reach me out and buy it. Yeah. So today we'll talk about React Native, and we will talk about Internet of Things. Well, before we talk about the actual things, let's think how the future will look like. Basically, yeah, it's kind of smart homes and things connected and trying to talk to each other, and sometimes they don't. So eventually we'll probably get to this type of like humanity destruction. But right now to the point, if we look at our world, we see that there are lots of things already that are smart. We have smart energy, agriculture, Internet of Things in general, really small, tiny things, and we have retail, health, mobility, you name it. And of course, we have smart homes. Who here have some types of smart light bulbs or smart homes? Good. So today, obviously, we can't cover everything out of this list, but we will today talk about beacons, and we talk about Bluetooth Low Energy in general. So what is a beacon? Okay, beacon is a small BLE, Bluetooth Low Energy radio transmitter. It looks like this. It's really small. I have two of them here. And it transmits a packet at interval of 1/10 of a second. And it can be in various formats. The most known formats are Eddystone and iBeacon. What is BLE in general? BLE is Bluetooth Low Energy, or it's called also Bluetooth Smart, and it's part of Bluetooth 4 core, meaning you have it everywhere because everywhere is Bluetooth 4. It has really low power consumption. It can run a year on common common battery. It has really low bandwidth, low latency, and most importantly, it can be discoverable by Bluetooth-enabled devices, meaning your phones. Before we dive deeper into what Bluetooth Low Energy is, how it works, and what our beacons are, I want you to be familiar with some terminology. Basically, in Bluetooth Low Energy world, we have peripherals, which are small devices. Like, for example, I have a beacon, I have this watch, we have smart bulbs, stuff like that. Meaning it's a really small device with really no processing power, and it can just send signals, and that's it. That's what it does. And we have centrals, which are basically our phones, our like smart home hubs, and stuff like that. In Bluetooth Low Energy, we're using two protocols, which are JAP and JATT. JAP stands for Generic Access Profile, JATT, Generic Attribute Profile. Let's look at the first one. In a nutshell, it means that this small device, or this small device, is sending packets, basically advertisement data, which is really, really small packet. And basically it means that when you go into your like a central, like your phone, and you search for devices, you will see the name of the device and like really basic characteristics maybe and stuff like that. It works in a way that you can ask the broadcasting device, you can ask to supply data, and then you get like scan response data back with the inner things that are explained later in the JTT profile. And then you basically can connect to device. But JP can be used for broadcasting. Can be used to broadcast 31 byte of custom data to whoever listens. And that's basically the mechanism that stands behind beacons. They can broadcast data, but it's really small. It's not like you're broadcasting ads or something. And there is the first one. There is URL or URI beacons, which are also called Eddystone or Open Beacon format, and it's part of Physical Web Core by Google. Eddystone beacons, they broadcast URL to anyone who have physical web compatible service. And we will do a small demo here. I have here like a custom-made device, which is basically NRF 5832, which says nothing to you. It's just like a Bluetooth chip to which I can connect via web Bluetooth. And right now I'm disconnected, which is bad. I will connect, I think. I pray to demigods. But I think I need to make sacrifices for lots of demos today, so we will see how it will work. Yeah, sure, we have errors. Something's wrong. I like when it happens, because it means that probably it's get. No. It's supposed to be advertised. Oh, really? Somebody spots an error? Okay, let's do it like this. Let's just do just a regular URL. Try it. No. Ah, okay. Yeah. I don't read logs, right? Advertise. Billy Eddystone. Okay, so I prayed badly, probably, to demigod. So let's just continue, and I will explain what's supposed to be, right? Okay, basically, if you're, if I would have, probably it's something with the hardware also. Basically, when you transmit an URL, if you have on Android, you have nearby application, then you will see notification with, try to broadcast my book, but probably advertise. Maybe there is a net block in the crowd. So yeah. So basically, you will see the notification in nearby app, or in iOS you can install Chrome widget, and you will see like a link there. But the thing is, it's not really something we as React Native developers would do. It's just like broadcasting URL, right? It's not like we integrate it with the app or stuff like that. So yeah, I have to upgrade Docker. So we will talk about iBeacons now. iBeacons really different from Eddystone in terms of they don't broadcast anything like URL or any data except of unique ID, which is 61 bytes, and major and minor number, and proximity in meters. So basically, it gives you an ability to know where this beacon is and how and what is the distance to the beacon. So why it's cool? Okay, so it's just a proximity tool, right? But it adds proximity-based layer of interaction with app users. It's really different. We actually know where the user is in physical world, so we can make interaction with him. You may say it's just a proximity tool. Okay, why shouldn't I put like a sensor or like motion sensor on the door and user enters and then something happens? But we're talking about really small devices which are really cheap and can be distributed across vast environments. And by letting your device, your actual device, know the physical context, we can change the way we interact with the user. Ultimately, it will lead to change in how you develop your apps. And right now, there are lots of apps that use beacons for indoor navigation, for example, proximity marketing, like you go to the store, and if you're in front of some clothes that you just looking at it, you will get in dedicated app, you will get an ad, there is a sale, 50% sale or something like that. Then we have automated check-ins. For example, think about hotel. You just download hotel app and you go to your room, and then it just unlocks automatically. And of course, there are also contactless payments and various other things. For example, this is an example of some ad from beacon-powered store. In dedicated app, they receive the actual ad. Or in museums, for example, you stand in front of an artwork, so you see this explanation of this actual artwork. Or in airport, you have really cool navigation, local-based navigation inside an airport. Something off with the slides, I don't know. So basically, by using physical context, we try to predict user intent. If you look at the center of the picture, like a square in the center, it's already what user does. He already searches for the artwork. He already checks in Google what this artwork means. And by providing him this interaction based on his actual physical location, we just eliminate unneeded action of searching Google. And by letting him know what he was supposed to see. So in general, guidelines for physical context-aware apps are basically enabling location services in your app. It's the first one, the most important one. The location services and Bluetooth, of course. Then we should start scanning for beacons. And we check closest beacon by their unique ID and by their minor and major numbers against some type of server. And then we execute custom logic. We can show notification. We can put some interactions inside our apps. But basically, we by connecting the actual UID and minor and major of beacon to data from the server, we can change our apps accordingly. So yeah, hope this will work. Let me just mirror my phone. Okay, great, that worked. And this also worked. Okay, so I have these two devices, wait. Okay, so I have these two beacons, right? So I have, this one is XY Tracker. It's basically the commercial product which you can put in your wallet and track your wallet. And this one is just the same one. I tried to send you an URL. The same, it's based on Esperino chip, and you can run JavaScript on it. So I made it an iBeacon. And let's see how it detects proximity. The first one in the list is the closest one. So right now we have XY Tracker, which is closer to the phone, right? And then I switch between them. And they're switched, right? How cool is that? We know in a distance of several centimeters, we know which beacon is closest, right? So we'll try more extreme ones. So I switch in them. No, it's just my phone went black. So Park needs some more distance, but you see they are switching. So basically by this we can write really a precise navigation system. Like we can, if, for example, in an airport, we can put just like tons of beacons and include pathfinding algorithm to make user move from one object to another object. And that's basically how it's done. And sorry for this technical issues. Probably it's him. Yeah, I know. I should talk to Ken Wheeler. It's his library. Okay. Yeah, and later if you want to see how it works, the video, basically the same demo I've showed you. So let's try now, go full screen again. No, it doesn't go. Let's just restart. Okay, we'll do it like that, I think. Sorry for that. Okay. Where is it? Here's it. Here it is. Okay, so we have, we need to, in order to create beacons powered up, we need to basically import the beacons from React Native Beacons Manager, its library. You can install it regular way. Then we, I have this kind of local database here. I just didn't set up a server, so we just have like a regions array with all the regions we have. And this is actual latitude and longitude of this building. And we have some unique ID. Then we have beacons registry, which are basically these two beacons. And they have the same unique ID, the ID for this region, the whole building. And they have different major and minors, meaning we can differentiate between them. And each one of them have, in addition to minor and major, has a name, image, and image URL. So now we set up geo accuracy. It's like decimal places after the just decimal places. It was like several minutes of testing where outside of the building geolocation goes off. So that's basically around 4. And then we just define our state. Then we need to request, obviously, authorization to use beacons. If we start an app, we see notification, do you want to use location services and beacons? You allow, and you're good to go. I get current position from Navigator. Geolocation with latitude and longitude, and then I basically filter all my beacons based on, including geo accuracy, based on latitude and longitude of the region and their actual unique, basically by latitude and longitude, and then I will filter them on unique IDs. Then when I have a region unique ID, I need to start ranging, meaning I need to start scanning for other beacons. And I need to provide identifier, which is basically a regular string that explains what region is. And unique ID, which is really important. It's the ID of the region you're in. And then I just add a listener to beacons did range and set my beacons if there are any. And of course, I need to check which beacons in the whole registry. Like here, I have only 2, but in whole registry, I probably have lots of them. So I need to filter them properly. it's like a demo app. In a real app, you obviously will fetch things from the server and like query things based on ID of beacons you have. This is how it's done. It's like you check unique ID of beacon and major and minors. And that's basically it. You have this app. Beacons are good, beacons are great. But beacons use BLE, right? And we talked right now only on regarding the GIP and the broadcasting mechanism. But we want to actually connect to devices, right? So for that, we will use JATT. JATT is generic attribute profile. And in the, under the hood, it implements IATT protocol to store services and characteristics in a lookup table. What does it mean? It means that we have a central and we have peripherals, and we have two-way communication. We can read characteristics, we can write characteristics, observe values, and stuff like that. In a nutshell, services are groups of characteristics based on grouped by functionality. Like, for example, here I have a heart rate. So it's heart rate service, which exposes several characteristics which are used to read, write, and observe. You can read variables, you can write variables, and of course you can observe values when they change over time. Basically, it looks like this. You have services which expose characteristics, and now I will pray again to demigods. Now, let's mirror my phone again. It's mirrored. And I have light bulb here. Everybody sees it? Ta-dam!
Can you put it higher?
Yeah. And now I can change basically everything. I can remove brightness and I can change color. I should move brightness back. Yeah. And I can, of course, turn it off, turn it on. And that's basically the small bulb. You can have it at home, right? So how it works? Wait, let me just disable this. So yeah, thank you, demigods. So yeah, we have a video here. I have a video here for if you want to check it later. So we use package React Native BLE PLX. It's package really awesome. It's based on it works with the RX Swift and the RX Java under the hood. And it's really reactive, and even though I used async await in demo, you can for sure use it with the RxJS, or you can just change promises. So what do? We basically take a buffer. It's a buffer package. Basically, I use it for creating base64 values. That's values I need to send to this LED bulb. And I take BLE manager. I know LED bulb unique ID. I can know this by using NRF Connect app, which basically lists all the devices near me, and I can just look at the name, and by the name I know this is the, with the name I see also the unique ID. Or if, for example, you have a specification for the specific light bulb, you will have it there. And then I create my manager. I have some things in the state. And basically, I use here a manager on state change. It's not the state change of the light bulb, it's the state change of the device. Meaning, if I enable Bluetooth or disable Bluetooth on my phone, this will get updated. And when I click on a light bulb inside the app, I basically run scan and connect, mostly function. And this function starts scanning for the device to connect to device, I need to know all the devices around and how to connect with it. So I start scanning. And if my device ID is this unique ID I defined before that, I stop scanning because I already I don't need to know other devices. I want this specific one, right? So then I just connect to my LAN, which is as simple as calling device.connect. And then I want to know what are services on it and what are characteristics. And I actually want to write specific characteristic on specific service responsible for the light, right? So I still need to call discover all services and characteristics. It's a method on a device which gives you, basically it starts scanning, it returns all the array of all services that are in the system. And then I create my value. It's some weird thing here. If you have like a high-end device like Philips Hue or something like that, probably in documentation you will get what characteristics means and what each characteristic is responsible for what. But if you have like this one, which is just a Chinese light bulb, you need to reverse engineer a bit. Basically, it's done by logging logs on Android, just taking them into to your computer and running Wireshark filters through them to know which you can filter by unique ID, which you have. And then you need to figure out the pattern, which values you need to send to the light bulb in order to activate colors. In this case, it's these values are constant, and the color I send is basically RGB. It's not that I just... so I send it like in base64 format, and then I write characteristics with the response for service for these specific IDs. You may say, okay, probably you hacked this light bulb and probably you know these IDs, where do they come from? So before that, I logged my IDs and checked which one has read property and which has write property. And there was only one service with only one characteristics which has had write property. And in order to log everything, I did this fancy function, which is I run here discover all services and characteristics, and then I call services. This will give me a service array. Then I need to map over service array and return each characteristic to build up the characteristic array. And in the end, I just log them. I check which characteristics has which like read, write, or notify. And then I have this value. So I hard-coded them inside the app. And that's basically it, right? So you have this light bulb, you have maybe more sophisticated devices, like you have this watch, you have really different things you can connect to. And I really encourage you to just go home and try out things and try to connect, I don't know, coffee machines. If you have a coffee machine with Bluetooth, maybe. Just connect things, build another crossbow, do things, and you were awesome. I told you about the book I published. So today until 10th of September, there's 50% discount code if you want. And I actually have a printed copy here. So I'm doing like kind of book raffle. So I will give a printed copy. Just tweet this lots of hashtags. The most important one is RN Book Raffle. I will choose the winner by it. And thank you all. Thanks.